Hello everyone, welcome to my channel. So today we are going to do one of the question of the blind 75 list. So we have already completed the retake cycle in a linked list. Now we need to go ahead with reverse a linked list question. So without further ado, let us start. So here, if we read this question, it just want to convey us that we are given with the head of the linked list and we are required to return the reversed version of that linked list. Means here you can see that it is pointing 1 to 2, then 3, then 4 and then 5. But what we need to return is that it should be reversed. Means 5, 4, 3, 2, 1 rather than 1, 2, 3, 4, 5. And that should be in every case. If it is null, then we need to return null. So now here if we check for the first point about the constraint, so the number of nodes in the list are in the range 0 to 5000. So means 10 raised to power 3. So if we go ahead with a solution of order of n or order of n log n, order of n log n, yeah, that will work fine. And if we go ahead with order of n square solution, that will become 10 raised to power 6, but that would be like completely near to the TLE solutions. So we will prefer to go ahead with order of n or order of n log n solution only as per the constraints which are mentioned. Then minus 5000 to 5000, that is the node value, but anyhow we are not that much concerned with node values. We are just concerned with that we need to just reverse it. We don't need to do any arithmetic operation on the same, so it's just reversing only. So that's why we were just concerned about the number of nodes rather than the value of the nodes. So now how we need to reverse the linked list means one of the today we will be discussing about the iterative version as well and the recursive version as well. Both of them we'll discuss. So those are two solutions we will be discussing. So first let us go ahead with the iterative version and then we'll go ahead with the recursive version of how to reverse a linked list, and side by side only we'll discuss the time complexity and space complexity. So now first about the iterative version. So how we need to do the iterative version. So in that case, see how we basically reverse a linked list. If you see, 1 minute. Yeah. So if we see that where is my cursor now? Okay. Okay. So this is the linked list being given to us. So if we are going ahead with the iterative version, so iterative version would be like we will be using a loop or something like that so that we can traverse this whole linked list, and we need to modify their links in such a manner so that it can become something like this, right? That would be the case. So in that context we will be using a few of the pointers which will help us to modify the original linking which is there of all the nodes with each other. So that we will be going ahead and doing in the iterative version. So if you see that, see how we can change the linking if we take the case of only 3 nodes, right? So if we say that it is this one the current node, it is the previous node, and it is the next node, right? And what we need to do actually is we need to do like in the original one it is like previous is pointing to the current and current is pointing to the next, but in the newer version what we need to do is that are 3, that is the next node, it should point to the current node and the current node should point to the previous node, right? So that would be the scenario which we will be required to return, and accordingly we will be modifying the pointers. So anyhow, all the 3 pointers which are there, we need to basically we are not required that at the start we are having all the 3 pointers. 1 minute, my internet has lost. uh, why there is no internet? mm. Okay, now my internet is restored, so let us go ahead. So now here you can see that things are something like this, right? The next pointer which is at that need to be pointed to current, and current need to point to the previous. And anyhow at the end we would be required to return the next pointer. This is what we can see from this particular diagram. But in actual, when we would be coding, these pointers would be moving ahead, right? And accordingly things will change. That would be the thing, right? So in that context we need to think of, like, as we need to modify all of the linkings, right? So what need to be returned so that we will be getting our final answer, and what need to be replaced with what, right? So in this diagram we can see that things would be something like this, right? So at the start, if we make current equals to head, and our previous and next pointer which would be there, both of them, let us keep them null only, right? So because anyhow we require one of the pointer which will be pointing the original linked list. That is the requirement, then only we can modify the original linked list, right? So that's why. Now the next thing which would be, what we need to do and go ahead would be like, so we will be checking, because this is having the original linked list with it, right? So our condition would be on this, that until the original linked list is not pointing to the null, we will be traversing that linked list, right? So this is what we will be going ahead because of this. Now comes the next part of modifying all the linkings, right? So how we need to do that? See, the thing is that we need to change the current and previous first, means if we go ahead with bit by bit, right? So first we need to change current and previous points which are there, means previous would be the previous one and current would be the present one, means something like this, and we need to do it something like this, right? So but for that purpose also, when we will be doing all this, we will be required to, whatever current would be pointing, we need to break that, right? When we will be breaking that, then the whole linked list which is ahead, that will be completely removed, right? So that scenario is not arise that scenario is not arise in future. So for that purpose what we'll do is, this next pointer which is there, so in this, whatever we will be having next to our current, right, we will be storing that in this next. That would be thing, just for safety purpose we'll store that, so that in future when we will be modifying these linkings, anyhow after modifying these linkings, we will, whatever was stored in next, we will store that back into the current, so that we can go ahead and completely the things are not that detached, and even we will be having we will be able to reverse the linklet side by side. So okay, just wait, let me show you one example so that it is more clear. Okay, see, what I'm trying to say is that if we take this 1, 2 and 3, right? So anyhow our current is only pointing this, and our next and previous are pointing to null, right? So what we'll do is, we'll assign next with the current next, right? That means that our next pointer which is there, that will be having 2 to 3, means this is the only linked list which is after 1, right? So it will be having linking to all this, right? Then what? Then at this point we were having current with 1, 2, 3, right? But whatever was next one, that is 2, 3, we have already assigned to next, right? The next pointer which is there. Now we can easily modify our current pointer. Means how we can modify that is, what we'll do is that whatever was current, what we'll do is that current will point to the next, means the current which will be trying to, means whatever current is, that is 1 at this point. So what will be next node, it will be pointing. So for that purpose what we'll do is, at this point we'll do current next equals to previous, that we will be doing, and previous is already pointing to null. So because of this thing, what it will happen is that 1 will now, rather than pointing to 2, now it will point to null, right? So that would be the scenario at this point. Now the next thing which we can do is, means previous was having something this, now we need to modify previous also. Anyhow, now the previous need to point something, so that when next we will be doing the same thing again, because anyhow we will be doing all these things again. So for that purpose, now previous will become equals to current. So at this particular point, now previous will become 1. Current is also 1 and previous is also 1, but now current is pointing to null. Earlier the current was pointing to something like this, but because of these two step, because of this step, just this one step, now current is pointing to null. Means current is having the linked list, but it is a modified version, and now the previous is equals to 1 and 1 is pointing towards the null. So this is the thing which is happening here. 1 minute. Okay, let it be. Okay, now let us go ahead. See, just by doing this, now comes the part where it's the original linked list which was there. So for that purpose, which we had already stored this next, right? So now current will modify, and it, whatever was in next, now current would be having that value. Anyhow our previous is having 1 null, right? Our previous is having that particular linked list which we are trying to modify, right? And now current will be having that linked list which was the original one. Means now current will be having 2 to 3. So this would be the thing. Now because all these things we are doing in loop, so this will repeat itself. Now the next will become equals to current next, and current's next means now current would be at this point and its next is 3. So now next would be 3 and the current next would be previous, right, at this particular point. So because of that, now current, that is 2, and its next, that will be pointing to the 1. So because of this, now 2 will be pointing to 1, and thus we are just one step, we are just in the next step of reversing our linked list, and like this only we will be reversing, and the complete linked list will get reversed. So now this is the thing which we will be going to code. Basically the thing was, we were required to observe that how we can reverse by using some of the pointers, and basically reversing a linked list we can reverse it in a lot of many other ways as well, but this way I found it much simpler by using 3 pointers and then modifying the links in between, and that's why I usually prefer to do like this in when it is asked about the iterative method. Else I usually prefer recursive one. So now let us code this. So basically we have like little bit things which are there. This only we need to modify and do code with the same. So now the first thing which would be there is list node star current, which will be pointing to head, and we are having the next pointer. Let us say it as next p, which will refer to next pointer, and this current also current p, which will refer to the current pointer, and this is a pointer, so we will be using star. Next p, which will be null, and then prev p, this is also the pointer star, equals to null. Yeah, so our 3 pointers are now ready to be used. Now we need to go ahead with a loop. So we will be using a while loop, and in this while loop we are using this current pointer, and what we are checking is that this current pointer is not equals to null. Until then we need to loop over. So now all things which I have explained here, this only we need to write. So the first thing would be the next pointer, that will be acting as a temporary pointer which will be storing the content of our current pointer. So this is what we will be doing, and then our current pointer which is there, its next will point to the previous pointer, so that at this point our links are reversed. Then next what we will be doing, so we will be making previous equals to current, so that we can move ahead in our linked list. Now the next thing which would be there, we will make current pointer equals to next pointer, so that whatever we had stored earlier, that will come, that we can use, and so that we can move ahead by reversing all others. Now at the end we will be required to return the previous pointer. And why we are required to return previous pointer? At this point only, if you can see that this p was having one null, the reverse version of the linked list, and this current was having the forward version, means the original version of the linked list, right? And anyhow next was having the next was just acting as a temporary storage only, right? So that's why here we are required to return the previous pointer, and that is what we are doing. So let us just run this code to check if there are any compilation error or something like that. So yeah, all are green, so that means it was able to pass it. Let us submit it. So yeah, it beats 100%. And one more thing was there, means apart from just what we say that, apart from just the iterative version, a lot of time interviewers also ask the recursive version as well. So that's why let us go ahead and code the recursive version also. So I'm just resetting this particular, and we'll go ahead and with the recursive version as well. So before we go ahead with the recursive version, let us check that how we can go ahead with the recursive version. Means how the base condition would be, what recurrence relation we need to follow, things like all that. Yeah, so 1 2 3 4 and 5. So in the recursive version, now the thing is the base condition anyhow it would be null only, right? That if our node becomes null, so we need to exit out, or if our head next become null, because when we are basically in the recursion, what all we would be doing is we will be checking for the next one also, means next pointer also, right? So that's why the base condition would be if head or heads next, if either of them is null, right? So we will just return the head itself. So that would be our base condition. Now comes the part for the recurrence relation, how in the recursion we need to write everything like that. So all those things we need to check now. See, if we the way earlier we were doing, we were taking 3 pointers, right? So now here anyhow whatever recursive function would be, so we will be passing that particular node, right? That particular pointer we will be passing, and we will be doing calculations, means we will be doing things in such a manner that we are able to change the linking of them, right? So That would be the scenario here. So for that purpose, if we take like recursive head which is there, means a recursive head and recursive tail, because when we are doing recursion, so anyhow whatever is head and whatever is tail, that we need to keep in mind. When the whole recursion would be completed, means when it will reach at this point, means when it will try to backtrack, at that point we need to reverse all the things which are there. That is the thing. We all know that when recursion is there, anyhow first it will move forward, call all the functions upcoming and ongoing it will, and when it reaches the base condition, that is this particular or this particular, right, then it will start backtracking, means it will start pointing towards its parent color, means returning towards its parent color, and that will be also again on the basis of the return condition which we will be writing here. That would be the thing. So now here the thing is, we will be taking rest head which will be calling our function, in which we will be passing the head which is there, and then this recursive tail which is there. Now this will help us in changing the linking. How it will help? So this recursive head which is there, and when it basically backtracks at that particular point, whatever would be the head, so we need to at that point whatever would be head, right, so head will be returning towards its parent, right. So what we need to do is that when it will be returning towards its parent, so at that point of tail we will be storing head next. That would be the thing. I'll show you with the example, then it will be much more clear. And then this would be thing, tail would be having heads next, and then the now this tail will help us. Now this tail will basically point towards the head, means this head's next which was there, right, so that will be pointing towards the head, and then we need to break the point, we need to break the linkage, like that, all that we will be doing. So if I show you all like this, it won't work, because I'm myself not able to explain much clearer. So it's better I explain with the diagram itself. So now see how the things would be, that at this point, means at 5, it has reached at that point where it will start backtracking, means it will backtrack to 4, right, means its parent color. Now at this particular point, the thing would be that now who will be the rest head? That would be the thing, rest head and the rest tail. So at this point the rest head would be 5, and the rest tail which is there, at this point the node was returned to the rest head, means to the 5 itself, right. So at this point rest head, rest tail, everything is 5 itself, right. That is the thing. But now what next we will be doing is that we need to make changes with this rest tail. That would be the thing. So for making the changes with this rest tail, means because we need to point it towards what was towards the next, right. So at this point of time, what we will be doing is minute 1 minute. Okay, now I'm back. So now see here, this 1 2 3 4 5, so we were having the base condition, right, that if head next is null or head is null, right, so we will be returning to its parent. So because of that condition our head next here refers to null, which is this 5, means the head was the 5 at that particular moment, so it got returned to 4. Fine. When it got returned to 4, so because of this thing, now the new head is 4, right. But At this particular point, the rest head, means the recursive head which is there, that is 5, which was returned to 4, and the recursive tail which is there, that is also 5, because what we were doing at that point was that we were doing the heads next, which is the 5, and that is what we were returning to 4. So recursive head and recursive tail, both of them were 5. Now the next thing which is there, that recursive tails next equals to head. So recursive tail which is at this particular moment as 5, so that's next equals to head that is R4. So because of that, the links would be reversed. And after this particular condition, the head at this particular point was 4, so heads next that will be pointing to null, that is this 4 which was there, that will be pointing to null, and then the rest head which was there, that was having the value 5 pointing to 4 pointing to null, and that would be returned to this particular 3. So that is how the things would be, and because of this thing we will be able to reverse our whole linked list. Means basically the recursive head and recursive tail which is there at the starting, both of them are same, and then we are basically changing both of the points which are pointings which are there, and because of changing of them and splitting of the head, we are able to link all of them. So now let us go ahead and code this particular solution, that will make more clear, and then we'll do a dry run, so that will make things more clearer. So now if head if head is null, or not head, or not head next, if either of these cases are there, then we will return the head itself. So because of this condition only, the 5 that was returned to 4, that was the thing, because we had reached base condition at this particular point of time. And then we will be creating a new nodes that is the recursive head and recursive head and recursive tail. So recursive head would be basically calling the function recursively again and again. So this reverse list function which is there, and the head heads next, basically here it will be checking if that particular heads next is null because of the base condition, then it will return the head, and that would be returned to its previous caller. And when it will be starting the backtracking part, right, so at that particular moment we will be having our list node star recursive tail as well. And this recursive tail, what it will do would be this recursive tail will store the heads next. At that particular point of time, our head was 4 and its next is basically the 5, right? So heads next, the 5 itself would be stored here also. Now we need to start changing our linkings. So for changing our links, the recursive tail that we need to anyhow we have that value, and its next we need to point it to the head. Now the recursive tail was 5, and now 5 will be pointing towards the head, that is the 4. Now the head next, who was the head? Head was at this particular moment as the what we say that head at this particular moment was 4. So now this head next, we need to change the linking. That's the thing. Earlier head, that is the 4, was pointing towards the 5, but in the previous step what we did, it is now pointing, means 5 is now pointing towards the 4, So that's why we need to change the previous linking of 4 pointing towards the 5. That's why we are making heads next equals to null. And the next thing, now the linking has been already changed and we need to return the new changed linked list to its caller. So that's why we will be returning recursive head. So this recursive head would be returned to its parent caller, and its parent caller basically would be 3. So now again the things will start going ahead the same way as it was earlier. So now it will be 3, and now 3 will be having the 5 pointing towards 4 and 4 pointing towards the null. Now the same things will start repeating here. The new head which would be that is 3, and heads next would be 4, right? So 4's next will become head, that is the 3, right? So here head next will be 4, and thus the recursive tail which is there, that will be 4, and that 4 next will be 3. So the recursive will again change, and the head next, that will become null. So that 3 which was pointing towards 4, now it won't be pointing towards 4, but it will be pointing towards null. And then at the end, we'll return the new linked list which is found at this particular point to the parent column. Now if we run this, so all are accepted. And yeah, it beats 100%. And yeah, it's all done. So here the time complexity and space complexity of both of the solution is order of n, as the time complexity, and the space complexity is order of 1. So if you have any doubt, you could comment that down. So this was all. Thank you.